Hello aviation enthusiasts, it's Otto from Otto's Aero Escapades, and today I am going to be talking about aircraft flight controls, specifically primary and secondary flight controls. So here's a typical little airplane right here with its flight controls, right? We got the primary flight controls, the ailerons, the elevator, and the rudder. Those are the flight controls that are going to control my aircraft through my three flight axes. My vertical axis, my longitudinal axis, and my lateral axis. So vertical comes straight up from the bottom to the top, and they all intersect at the center of gravity. My longitudinal axis goes from the nose to the tail, and my lateral axis goes from wingtip to wingtip. So the three primary flight controls are going to control my flight along these axes. So, and also, I said they all come up through the center of gravity, but here's the center of lift. This is typically how an airplane works. We got the center of gravity, and then we got the center of lift on the airfoil. So the three axes come up through the center of gravity. Center of gravity. So here is a Boeing 737 with its primary flight control. So these flight controls are going to have redundancy built in. There'll be maybe three hydraulic systems going to each of these systems out here. So we have redundancy, so we can control our airplane no matter what. So we got the ailerons on the trailing edge of the wings. We got our elevator right here, and then we have our rudder right here. And sometimes it's a split rudder. It depends. So flight controls along our axis of flight. So the lateral axis right here, the lateral axis is from the wingtip to the wingtip. I already said that. The vertical comes up from the bottom to the top, and the longitudinal from the nose to the tail, and they all intersect at the center of gravity. So here is the lateral axis, and what controls my movement on the lateral axis? The elevators, So the lateral, right? A lateral pass in football, lateral. So the lateral axis, the elevator controls the movement on that axis, and we call it pitch. Pitch up, pitch down. So that's your elevator out there on your empennage. Now, the longitudinal axis goes from nose to back, right? It goes right through the airplane, So, for movement on the longitudinal axis, we're going to have ailerons. And it's lateral movement. So there's your ailerons moving your airplane, right, on the longitudinal axis. And of course, if you've ever been on an airplane, the ailerons don't move this much. They barely move at all. I like watching them when we start banking when I'm flying, and you can barely see them move. So it doesn't take much movement of the ailerons to make an airplane bank. Now notice, one goes up, one goes down, right? One goes down, and it's like a flap, creates more lift, and then one goes up, and it acts like a spoiler, which is a secondary flight control, and we roll. So we call this movement rolling movement. Now, the last axis of flight is the vertical axis, right? So it's coming up through the aircraft, and they all meet at the center of gravity. So what's going to control our airplane on the vertical axis? It's the rudder. The rudder. So you could have a rudder vader like this right here on the Beechcraft Bonanza, or you can just have a regular rudder that we're used to on big aircraft and even small aircraft. So the rudder moves my aircraft on the vertical axis, the rudder. So those are your three axes of flight, and those are your three primary flight controls. Rudder, ailerons, elevator, right? Those are your flight controls you do not want to lose. You're going to have redundancy built in, and any kind of emergency power is going to be able to supply hydraulics out to these systems, because you definitely want your primary flight controls. Now, secondary flight controls are just niceties, right? We don't really need them, but they help us manage our takeoffs and landings and flying, right? Nice and straight and level. They're all niceties. That's why they're called the secondary flight controls. We really don't need them. You know, if doo-doo hits the fan, we don't need them. All we need is primary flight controls. So we got our leading edge flaps, our leading edge slats, our trailing edge flaps. We got spoilers, right? And we got ground brakes, ground spoilers, and trailing edge flaps. And they're all there to help us fly and make our job easier. But they're not needed. So flaps, they're basically extends the camber of the wing. That's their design, to extend the camber of the wing. So the most often used lift modifying device for a small airplane and large is the wing trailing edge flap. There's 4 kinds of flaps out there today that I know of. Now there could be another one. You could tell me in a comment if there is, but there's 4 different types of flaps that I'm aware of. We got the plain flap, the split flap, the Valor Flap, and the slotted flap, and we'll take a look at them. Here is the plain flap, like on the Cessna 150, 172, right? They're part of the wing. They're part of the wing. When they're not deployed, they're actually part of the wing. And then when we deploy it, you can see how we increase the camber of the wing surface, and it helps us create more lift at slower speeds. Here's the slotted flap right here. It's not part of the wing. It's not part of the wing. But what's unique about this is it lets some of that high energy air that's coming from under the wing, it allows it to come across the top of the flap and increase the velocity in the air. And according to Daniel Bernoulli, if you don't change the energy in the fluid, which is the air, if the fluid increases, pressure decreases. So there is our split flap. Now here's the Valor Flap right here. So basically when it deploys, it moves aft. In addition to deflecting downward, it increases the total wing area. So not only, it just doesn't go down, it extends and then goes down. So it increases the wing area, but it's also slotted. So some of that high energy air from under the wing can come across the top of my surface and help create lift. What you want to do is create lift so you can go slower, so you can come in for a landing. But it's a secondary flight control. You don't need flaps to land. You're going to come in fast, right? but normally there's airports big enough to handle coming in fast. Now, some of the stuff you might see on the leading edge of wings, here's a leading edge slot. It doesn't move at all. It's just built in and it stays in that position. But it's also designed to let some of that high energy air come up through and across the top of my wing to help keep the boundary layer nice and smooth and sticking to the surface of the wing so we don't get a stall. Or we could have leading edge flaps, which we can't see, and leading edge slats right here. In this picture, I don't know if you can see it, but the leading edge slats and the flaps inboard and the trailing edge flaps are extended. So if one's extended, the other is extended. And I don't know if you can see, but there is a slot right there to allow some of that high energy air to come up and over the top of my wing to help with that boundary layer. But they're all designed so we can produce lift. Obviously, if you're going to produce lift, you increase drag. So it's great, but it does increase drag quite a bit. So we like to have these leading and trailing edge flaps so we can slow down and come in for a nice smooth landing. So one of most of today's commercial airlines, the leading edge slats deploy when the trailing edge flaps are lowered. So that's how it works. Now, how about spoilers? It's exactly what their name says, spoilers, right? We know this right here, this top part of the wing, it's got camber, so the airflow has to speed up going across it, and you know if velocity increases, pressure decreases. But here, these flaps stick up into the wind, and they spoil the airflow going across the top. It's exactly what they're called. Spoilers. Spoilers. They spoil the lift of the wing. Now you can have ground spoilers, which is going to deploy as soon as you touch down, or like it could be like a speed brake, right, to slow you down. You got roll spoilers, which will actuate at the same time your ailerons actuate. Yep, and then you got speed brakes out here that'll deploy in flight if need be. So that was the leading edge, trailing edge flaps, the spoilers, the ground brakes. How about trim tabs? Trim tabs are there because not all flight control surfaces are perfectly rigged, right? They might be a little bit off. So you might have a tendency of one wing producing a little more lift than the other, or you're pitching up or you're pitching down. We want to be able to trim that slight discrepancy out so we can fly straight and level. So we do this thing called a trim tab. A trim tab. You can see here's my horizontal stabilizer. There's my elevator, right? My elevator. And the trim tab will help actually with moving my elevator, but also if I had to trim it nose up, I could do that. Its purpose is to create an aerodynamic force that keeps the flight control in a deflected position. So if you needed a little trim for nose up, so you can fly straight and level. You got trim tabs, you can have them on your elevator or on your rudder right here. Elevator trim tabs, rudder trim tabs. It's all to help us fly nice and level and take the fuss out of always having to keep your hand tightly on the yoke. You also have an anti-servo tab. An anti-servo tab is basically, you'll find them on a stabilator. which is a stabilizer and elevator all in one. So if you have a stabilator, you're going to have an anti-servo tab, because moving the flight control is rather easy, right? So you want to have some resistance there, and that's what your anti-servo tab will do. Yep, stabilator. So, because the location of the pivot point for this movable surface, it has a tendency to be extremely sensitive to pilot input. So to reduce the sensitivity of your stabilator, a full-length anti-servo tab is installed on the trailing edge of the stabilator to give you some resistance. Your resistance, you actually got to work for it a little bit to move your stabilator. And that's what the anti-servo tab's for. So, that's it. That was just a little down and dirty preview of primary and secondary flight controls. You know, primary flight controls, you absolutely need them. You need them. They're going to have redundancy built in. You might have an A system hydraulics, B system hydraulics, C system hydraulics, and they're all feeding these flight controls separately. Or you might have fly-by-wire, right? But you're still going to have different branches of electrical circuits going out to these. You might have an A branch, B branch, C branch, D branch, right? And that's just for the electrical signal. You need hydraulics going out to the actuator. So you might have several hydraulic systems. So primary flight controls, your elevator, your aileron, and your rudder for controlling the aircraft on the 3 axis of flight, which is longitudinal, lateral, and vertical. And they all meet at the center of gravity, not to be confused with the center of lift on the wing. So, that's the primary flight control. Secondary flight controls helps us with our flight. It helps us with managing our flight. It's not so hard, right? Yes, you can land without flaps, right? But you're going to come in fast. You can live without trim. You'll just have to constantly hold the yoke to where you want it to be, right? So those are the nicety. You don't need spoilers. We had airplanes long before we had spoilers, so we don't need to be able to lose that lift without gaining speed, right? We don't need any of that stuff. Just the primary flight controls is really what we need. So, maybe one day we're going to see this type of airplane right here. Who knows? Could that be the future? We don't know. But I'm Otto from Otto's Aeronautical Escapades, or Aero Escapades and whatnot. I will see you next time. Have a great day. Bye.